Graham, a propulsion engineer at European Astrotech. I started working here 4 years ago in the chemistry department, doing propellant analysis and chemistry compatibility work. I'm also in charge of the educational outreach project at European Astrotech, which is based around high-altitude ballooning. High-altitude ballooning is a really good way of teaching kids about the space industry and engineering. We specialise in propellant and rocket fuel, which is obviously far too dangerous to take into schools. So instead, I teach them science and engineering through launching high-altitude balloons to the edge of space. So it contains a lot of the same elements as we would have in a normal launch campaign, but none of the dangerous parts. So we're using balloons to propel ourselves to the edge of space rather than rockets. One of the lessons we do in our education outreach project is on tracking and telemetry. So this is really important for all satellites and also for high-altitude balloons. So it's one of these parallels between high-altitude balloons and the space industry. So here I've got a Raspberry Pi computer, which is about £25. It's a miniature computer that does pretty much everything your laptop or PC will do, but you can attach lots of cool and interesting things to it. So what I've got on here is a GPS module, so it allows us to track the balloons live during the flight. And then on top of that, I've got what's called a sense hat. So this actually went to the International Space Station. Tim Peake did some experiments on that, and it's got lots of cool sensors such as magnetometers, pressure, temperature, accelerometers, etc. So lots of fun experiments you can do with that. And I'll just plug it in so you can see how it works. So this is the LED screen, and you can send messages across the LED screen. But what we're going to use it for is sending radio waves. So the students would make an antenna which would attach onto this port here, and would send the signals down to Earth when the balloon is flying about 30 kilometres above the Earth. And then they'd be sitting in mission control or in the tracking van with a radio, a laptop and an antenna on the ground. So they'd make a simplified version of this Yagi antenna. So if I turn on the radio now, we just have to tune in to the correct frequency, and you should be able to hear the signal from this Raspberry Pi. So that's just being sent out of the radio module here. So you can hear it's a bit of a weird alien sound, but that noise actually contains all the telemetry information, such as latitude, longitude, altitude, and any other sensor data that you want to program into it. What happens to this noise? Obviously we can't translate that just using our ears, so we send this noise into a computer, and it will show us all the telemetry sentences in numbers and letters that we can understand. This is then uploaded onto a website, which shows on the map where your balloon is. So you'll see on this map, follow your balloon throughout the entire flight, and then if you're going to recover your payload and collect all the stuff that's in it, then you can see exactly where it is in real time. As well as this, we have a camera, which is also attached to the Raspberry Pi, and we can send live images down to Earth as well, so you can see exactly what's happening during your flight in real time. Normally we run the education outreach project as an after-school activity or a lunchtime activity. We also do one-off launch events, so it's extracurricular, and the students want to be there. It's not part of their curriculum. They we enhance what they learn in the curriculum, so we use a lot of the physics, maths and chemistry that they will do at school, but we apply it to a real-life project, and the result is that they send something that they've created and designed into space, and they'll do their own analysis on their particular experiment. Unfortunately, we find that for these projects, only about 10% of the students are female. They do always have a more commanding role, and they're often project managers of the group, which is really nice to see. But I think there is a drop-off after GCSE of girls in physics and maths especially, and this is another reason for doing the project. We do it with younger students as well, and just to show them what physics and maths can allow you to achieve, and the involvement we have with space and the space industry is really inspiring for students, because I think there is a kind of innate excitement from when you're a kid that stays with you, but if you're not exposed to it anymore, then you forget about it. So we're trying to remind them of this innate excitement which they have for space and exploration, and this project is about rekindling that, because they are building something and sending it to space and seeing what happens. It's easy to get excited about, it's easy for me to impart excitement to the students, because I myself am still very inspired by the space industry and how we can push the boundaries of space technology. It started when I was very young. I always wanted to be an astronaut, like pretty much every other kid, but that excitement kind of stayed with me, and I pursued science and maths because that's what I enjoyed. And I was lucky enough to go to some camps like the space camp that European Astrotech puts on, and see maths and science applied to real life projects, which gave me a kind of vision of what these school subjects, which can seem kind of boring at the time, what you can actually do with them. So that's the purpose of European Astrotech's Education Outreach Project, is to show students what physics and maths are actually capable of, and the hands-on applications.